Wow, what a beautiful bowl. I love the greenish blue color and repeating designs.
It says here this bowl was created around the 13th century in Kashan, Iran.
Looking around at all the Islamic artwork here, it's so beautiful. And a lot of the designs remind me of math. It's like the artists didn't separate beautiful things from mathematical things. They saw math and beauty together. It's really amazing. I wonder, what is mathematical about the patterns we see here in this bowl?
That's a super interesting question. We could start with the pattern on the outside. It looks like handwriting, doesn't it? Repeated over and over in a pattern circling most of the bowl. That forms a repeating pattern.
I can't read that type of text, but I know that one of the major types of designs in old Islamic art was calligraphy.
Calligraphy is the art of writing things in a decorative way instead of just normal handwriting.
I noticed that both the calligraphy and plant patterns are spaced slightly apart, and the same exact shapes are repeated all around the bowl. No matter which way you turn it, it looks just about the same. That means it's a symmetrical pattern.
Yes, I definitely see a lot of symmetry in the design. You can almost imagine these designs as moving around a fixed point or rotating, like you see in this pattern moving around the circle here. It's rotating. That means the pattern has rotational symmetry, right? I wonder what order of symmetry do you think this bowl has? For example, an equilateral triangle has an order of symmetry of 3. Order of symmetry means that if you imagine turning the triangle, it would exactly match up with itself 3 times.
Let's see. I'm going to look at the points of the star shape in the middle to help me figure it out. I would say 6, because you can turn the bowl once and it matches up with itself exactly. Then again and again. That's 6 times, so its order of symmetry is 6.
If it matches up with itself 6 times, then each rotation would be a 60-degree rotation, because 360 degrees divided by 6 equals 60 degrees. So we could also say that this bowl has 60-degree rotational symmetry.
Cool. I wonder who used this bowl and where.
It would have been used by either royalty or other members of the upper class, probably in their homes, as a serving bowl or a container of fruit. You know, the bowl was made during a period of great wealth to Iran that came from a trade along the Silk Roads. As a result, upper classes invested a lot of time and money into decorating their homes with such ceramics and other beautiful things that you might see in this gallery, like incense burners and very ornate candlestick holders.
Yes, walking around this gallery earlier, it definitely looked like the combination of geometric, plant, and calligraphy motifs was very popular in the Islamic world.
Geometric patterns played a huge role in Islamic art, from ceramics to architecture, because these patterns can be repeated infinitely.
Infinity means forever and ever, unending.
Exactly.
Going back to our question of what's mathematical about the patterns we see on this bowl, there's really a lot. The repetition, predictability, and symmetry makes these patterns mathematical, not to mention that it was made during a time period when there was the actual discovery of so much that I learn in math class today. That's just mind-blowing.
Did you know that our modern English words relating to math are actually just borrowed from Arabic? Algebra, algorithm, average, cube, and degree, for example. And that's barely scratching the surface.
So, whoever designed this bowl was living in a time where people were surrounded by mathematical patterns, with rotational symmetry, like we talked about, with repeating geometric patterns, and with plant designs. I'm just imagining our bowl in a stunning room right now.
It would be fun to try to draw what that room really looked like, using calligraphy, continuing the plant and geometric shape patterns onto the walls and carpets. There's a lot of incredible mathematical art you could learn.